Good morning, students. In the previous video, we discussed about the physical properties of metals and non-metals. And in this video, we will be discussing certain chemical properties of metals and non-metals. You know, oxygen is there all around us. So metals react with oxygen under different conditions. And what is produced? Metal oxides are produced. M plus O2 is equal to MO2. M stands for metal and O2 stands for oxygen and MO2 stands for metal oxide. So here I would like to tell you that some of the reactions are vigorous while some other are very low. It means that some metals react vigorously in the presence of oxygen as well as moisture and some react very slowly. Before discussing about various reactions, let us discuss about activity series. What activity series means? Based upon their reactivity, the metals are arranged in a series which is known as activity series. You can find the names and symbols of certain metals. These are the most reactive metals, and here lower side the least reactive metals are kept here. So because we have potassium and sodium on the top, so sodium reacts with oxygen producing a lot of heat and light, and when the reaction is over, sodium oxide is left. Here you can see from these equations, sodium and oxygen, when these react with each other, sodium oxide is formed. Here potassium, when reacts with oxygen, potassium oxide is formed. Now I would tell you that potassium and sodium are so reactive that they can catch fire immediately when brought in contact with air. Clear? So that is why these cannot be kept outside open. They form respective oxides very quickly. So these metals are stored under kerosene oil. Clear? So that they should not come in contact with air as well as moisture. Then next is these potassium and sodium, when they form metal oxides. If we dissolve these metal oxides into water, what will happen? Metal hydroxides are formed. Sodium oxide react with water to produce sodium hydroxide, and potassium oxide react with water to produce potassium hydroxide. Now these hydroxides are basic in nature and these are used for making the soap. Clear? Next point is calcium. The next metal in the list is calcium. Calcium is again reactive, but not as reactive as sodium and potassium are. Calcium forms calcium oxide when it reacts with oxygen. This oxide or lime, as it is commonly known, when it is dissolved in water, it forms calcium hydroxide or lime water. Here is the equation for this: calcium, oxygen, calcium oxide. Calcium oxide, when dissolved in water, calcium hydroxide is formed. Then this lime water is used. This lime water is used to test for carbon dioxide gas. Next is magnesium, aluminium, iron, copper. These are the metals which react slowly in the presence of air and moisture. Only a thin layer of oxide is formed on their surface when these are burnt in air. Otherwise, these are very slowly reacting metals. But when these are burnt in the presence of air, a layer of oxide is formed on the surface. Then magnesium. Magnesium burns with a dazzling white light. We are talking about burning in air. Magnesium otherwise is not so reactive, but when we burn this magnesium in the presence of oxygen, what happens? It burns with a dazzling white light and forms an ash-like powder. Magnesium, oxygen, here magnesium, oxygen, magnesium oxide, white ash. Clear? This ash-like powder of magnesium oxide, when dissolved in water, produces a solution. A hydroxide solution is formed. Clear? Which turns red litmus paper blue. That indicates that the oxide is basic in nature. Let us understand this with the help of this video.
When magnesium ribbon is burned in presence of oxygen, it forms magnesium oxide. If the ash obtained on burning of magnesium ribbon is dissolved in water and test with red and blue litmus papers, you will find that the red litmus paper turns blue. This is because magnesium oxide formed is basic in nature. So, we can conclude that metals react with oxygen to form basic metal oxides.
It is very much clear from this activity. Acids turn blue litmus red and bases turn red litmus blue. Just to make it very much understand and to learn this, I have created this. ABR, BRB, that stands for, A stands for acid, B, blue litmus turns red, bases turn red litmus blue. It is just to remind yourself, ABR, BRB, just keep it in mind. Then we were talking about metals, so here comes iron. Iron forms a coating of hydrated oxide, also known as rust. Both oxygen and water are essential for rust. Oxygen and moisture are present in the air, so when they react with iron, this is a very slow reaction, it forms rust. It is a hydrated oxide of iron. Rust forms a suspension in water. It does not dissolve, it does not settle down on the bottom, it remains suspended in the water. This suspension does not change the color of either blue or the red litmus. So the nature of rust cannot be tested with litmus paper or the litmus solution. So we cannot find out whether it is acidic or basic in nature. Next comes copper. Copper vessels are coated with a greenish deposit, as we have discussed while discussing the physical properties that metals get tarnished easily. So copper vessels reacts very slowly. Copper reacts very slowly with oxygen, and a coating of greenish material is deposited on the surface when it is exposed to moist air. What is that layer? That layer consists of mixture of copper hydroxide and copper carbonate, because oxygen is present in the air, water, moisture is present in the air, carbon dioxide is also present in the air. What happens when these things react with each other? Copper hydroxide as well as copper carbonate is formed. That is why this greenish color is there. Then when heated strongly, as we have discussed, iron and copper do not react very vigorously. The reaction is very slow. It takes a lot of time. But when these are heated strongly in the presence of oxygen, it burns quickly, and the respective oxide is formed. Clear? It does not burn actually. Now, when iron and copper is heated strongly, their respective oxides are formed, but they do not burn. It cannot be burned, but the respective iron oxide as well as copper oxide is formed. Then metals lower down in the activity series like gold and silver do not react with oxygen or air in any temperature. You can see here, this is the series. These are the most reactive. When we go down, the less reactive metals are there, and you can see silver, gold and platinum. These do not react with oxygen in any condition. Thus we see that in the presence of moisture, most of the metals get corroded. Most of the metals get corroded till copper we have discussed. So what happens? Certain metals, when these are heated in the presence of oxygen, they do not burn, but they form their oxides. And those oxides which are formed with the reaction of oxygen, these are basic in nature. Clear? The reactivity series predicts that the elements will react more reluctantly. The reactivity series predicts that the elements will react more reluctantly with oxygen and therefore with air, which contains 21% of oxygen, as you go down the list. This turned out to be true. For example, if you heat metals in air, potassium burns very quickly, vigorously, even after gentle heating. Sodium burns so quickly, it liberates a lot of heat and light. Iron will burn, but only if heated strongly, and in the form of powder or thin wire only. You cannot burn a piece of iron. You can burn iron powder or thin wires. Copper will not burn at all, however hard you heat it. Will not react if heated strongly. And if you heat strongly, then only a layer of black copper oxide on the metal will form. Gold will never react, even if you heat it very strongly. Gold, silver, and gold and platinum do not react at all. Then here is I have made a little, I have used this table just to make you understand. Potassium and sodium, these burn vigorously and form metal oxide. Calcium, magnesium, aluminium, zinc, and iron, these burn with decreasing vigor down the series, and these form metal oxides. Then lead and copper and mercury, these react slowly when heated and form an oxide layer. And you can see silver and gold, they do not react. Never. They do not react at all. So I have made this also just to, I'm sharing this. If you want to remember, if you want to learn this series, there is a jingle. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. This is a line which actually help you to learn the activity series. P stands for potassium, S stands for sodium, C stands for calcium, M stands for magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold, and platinum also. So till now, we have discussed the reaction of oxygen with metals. Let us discuss the reaction of non-metals with oxygen. Non-metals. Now, metals were producing basic oxides. Now, what is the difference? Non-metals react with oxygen to form acidic or neutral oxides, except white phosphorus. Their exceptions are always there. Non-metals do not react with air at room temperature. Non-metals are kept on room temperature, but they do not react with air. For example, sulfur and carbon burns in air when heated. When you heat these sulfur and carbon, then they react with air. What they form? Sulfur dioxide and carbon dioxide. Clear? Phosphorus burns with air to form phosphorus pentoxide. Let us discuss it, elaborate it more. Sulfur, when reacts with oxygen, it forms sulfur dioxide. Carbon, when reacts with oxygen, it forms carbon dioxide. Phosphorus, when reacts with oxygen, it forms phosphorus pentaoxide. Phosphorus pentaoxide. Okay, these oxides dissolve in water to give solutions which are acidic in nature. Sulfur dioxide dissolves in water to form sulfurous acid. Sulfur dioxide, water, sulfurous acid. Sulfurous acid turns blue litmus red, indicating its acidic nature. Let us understand this with the help of this activity.
Collect some sulfur powder in a watch glass. Burn the sulfur powder using a burner. Collect the fumes which are obtained by the burning sulfur in a test tube. Add a few drops of water in the test tube. Now, shake the test tube. Take both blue and red litmus papers. Dip them in the resultant solution. Observe the changes in the color of both the litmus papers. In this activity, we have observed that the blue litmus paper turns into red color and the color of red litmus paper remains unchanged.
So it is very much clear from this activity what happens. Let us move further. You have seen here blue litmus is turned into red. That is why, because sulfur hydroxide which we have made here is acidic in nature. In excess of air, sulfur burns to form sulfur trioxide. Now, if the air is excess, if the oxygen is excess, then what will happen? Sulfur will burn into sulfur trioxide. And then when this sulfur trioxide will be dissolved in water, what will happen? Sulfuric acid will be formed. And sulfuric acid is a very strong acid. Similarly, carbon dioxide forms carbonic acid and phosphorus pentoxide forms phosphoric acid. And here are the equations: H2CO3, H3PO4. These are the symbols for carbonic acid and phosphoric acid respectively. So what happens? These are quite acidic in nature. Then nitric acid, HNO3, and hydrochloric acid, HCl, that two other strong acids. Nitric acid is obtained by dissolving the oxides of non-metal nitrogen in water. Clear? Nitric acid is made by dissolving nitrogen oxides into water. Then hydrogen reacts with oxygen to form water, which is a neutral oxide, because we have discussed that non-metals react with oxygen to form either acidic or neutral oxide. So here comes a neutral oxide. You drink the water that is neither acidic nor basic. The oxide does not change the color of either blue or red litmus paper. So how this happens? Hydrogen, when it reacts with oxygen, it creates water. So water is a neutral oxide. Earlier we discussed the metal oxide. Iron rust is a neutral oxide. So here again, water is a neutral oxide. So this was all about the non-metals reacting with oxygen. So next, we will be discussing the reaction with water. That I will cover in the next video. So I'm stopping here. I'll be discussing the reaction of metals and non-metals with water in the next video. Till then, have a good day. Stay safe. Stay home.